Hi, this is Dr. Taft with one last video about descriptive statistics. In this one, I'm going to show you how to use a spreadsheet to compute descriptive statistics. So I have, I have the values of the first 19 digits of pi again here, and they are sorted so that you can make a nice cumulative distribution graph, kind of like the cumulative percentage graph that we saw in SPSS in the previous video. So you can see there's two values of 1, 2 of 2, 4 of 3, and you can see that as it goes along, this is showing you what proportion of the data are as big as this one or smaller. So our median is here. This is the third quartile. Here's the first quartile. So it gives you a nice visual representation of data. This is called a cumulative density plot. It goes from 0 or close to 0 up to 1 or close to 1. All right. Now we'll start by showing how you compute your different measures of central tendency. So our first measure of central tendency is the mean, and we compute that by using the function average. And I have made a named range. I selected all this stuff, and I right-clicked it, and I said define named range, and I called it pi data to save myself some time. And so I just say average, and then the argument that goes in is the range you're averaging, and then it pops out the average. And if you recall from our SPSS video, that gave us the same answer. So similarly, there is a median function. And again, you have to type equals first so that SPSS knows that you are, the spreadsheet program knows that you're asking for computation. And then you say pi data. If I didn't have the equals in there, it would just show us the text. We want the computation. So we start with an equals. Great. And then, shockingly enough, mode also has a function built in there. So mode counts the most frequent occurrence. This doesn't work as well for alphabetical data, just like these two don't work for alphabetical data. So you don't want to use this for like names. So even though I said previously that mode is the best and the only argument you can use, the only measure of central tendency that works for nominal variables, that is not the case for the mode function in many spreadsheet programs. So if you clicked on this to give yourself information, it would tell you that it has to have numbers, but it'll give you some hints on other ways to do that, like count if. Is a way to count non-number things. Okay, so those are our measures of central tendency. Now for our measures of dispersion, you have to compute some intermediates. So remember, the range is the maximum minus the minimum. So we have the max function for that to calculate the maximum. So it's so common that it's abbreviated as max rather than written out as maximum. And min, because this is such a common operation that it's abbreviated as min rather than minimum. So you see that so far the only one of these that doesn't have an exact matching name is mean. So it's called average, and it's not the mean function that generally doesn't exist in spreadsheets. That you call it average. We want to call it the mean, though, when we're talking about it for a variety of stats, math, nerd reasons that you don't actually need to know, but you'll sound smarter. So then here with range, we just have a formula here where it said, all right, we know the maximum is here in K8. We know the minimum is here in K7. So subtract those suckers, and that gives us the range. So 9 minus 1 is 8. That makes sense. So the sample variance, var.s, you have to put this .s so it knows it's the sample variance. The sample variance is computed taking into account the fact that in order to compute the sample variance, you also have to compute the sample mean. So it needs that n minus 1 in the denominator, not the full sample size. So that's why the sample variance is there. Likewise, sample standard deviation, that's stdev, St. Dev, .s, and then the input range again. That gives us standard deviation. You see those two are exactly the same as we found in SPSS because they use the same formula. Now, percentiles, like the median, if there's a tie, if there's an even number of samples in your group, you might not have an exact number. And so tie breaking works differently in different computers. And so this percentile pi data 0.75, which is one way of computing a percentile, it gave a slightly different answer than SPSS did. SPSS gave 8 as the answer, and Excel, or Google Sheets in this case, gives 7.5. That's okay, it's not a huge deal. So that won't match, and so that means our interquartile range will match. I used a different function here, quartile. So it says, this has 2 arguments. The first argument is where the data came from, but then we also say which quartile we want. So the answers could have been 0, 1, 2, 3, or 4. Right? So if I did the 0th quartile, it would say the smallest number. If I did the 4th quartile, it would be the biggest. And if I did the 3rd quartile, it would be same as 75th percentile, but we want the 1st quartile, so we're going to say 1. There's multiple ways to calculate percentiles. So then just like when we calculate a range, the interquartile range is the 75th percentile in K13 minus the 25th percentile, or the 1st quartile, in K12. So 3rd quartile minus 1st quartile, 75th percentile minus 25th percentile, either way. I don't know if I mentioned this in the previous one, but the cool thing about the interquartile range is that half of the data, by definition, goes in there. So that's one reason it's a nice measure of dispersion for discrete ordered variables. All right, I am done with measures of, well, descriptive statistics. Sweet. Have a good weekend.